In the first question, we have to find the correct option. The first option is total charge of the universe is constant. Obviously, this is the charge conservation. Total charge should be constant in a closed system, and universe is also a closed system. And B, total positive charge or total negative charge of the universe is constant. These two statements are wrong because the total positive and negative charges may vary. As in nuclear reactions, a neutron, which is a neutral particle, is converted into positive and negative charges. So we cannot say that the total positive charge will remain constant. And the last option is total number of charge particle. As I have already told, when neutron will be converted to positive and negative charges, obviously both will increase or both will change. In the second question, a charge is brought in an electric field. The electric field at the nearby points may increase or may decrease no matter we are bringing positive or negative charge. So we can visualize this. Just assume a field towards positive x-axis and place, let's say, positive charge. On the right side of the field, it will increase, and on the left side of the charge, the field will decrease because it will be opposed by the electric field of the positive charge. Whereas if we place a negative charge on the right side, the field will decrease, and on the left side it will increase because it will be supported by the electric field of the point charge we placed at the point. So it may increase or decrease. It depends where we are bringing the charge and where we are observing its effect. In the third question, it is asked that can we predict the value of E or V by knowing the other's value? Just say the value of E is 0, V must be 0, or V must be non-zero. It can't be because they are not directly related. Electric field is the rate of change in potential. Again, rate of change in potential. How potential changes, not the value of potential. Okay, so if E is 0, we can just say that V must be constant. It will not change in the direction where field is 0. So we cannot predict its value. Or if V is 0, E may be anything, because if V is 0 at a point, it may have some positive or negative value, or it may vary with any rate. So field may be anything. So these all four statements are wrong because they are just using must, cannot be. So the answer will be, if E is 0, V may be anything. If V is 0, E may be anything. And they can be 0 simultaneously, they can be non-zero simultaneously. One is 0, another is non-zero. All possible cases can take place. In question number 4, it is specified that the potential decreases from 120 to 80 volt if we move 2 centimeter along x-axis. Okay, as the potential is decreasing uniformly, we can say the field is uniform, and along x-axis its component is decreases 40 in 2 centimeter. 40 volt in 2 centimeter means 20 volt in 1 centimeter. So the field is 20 volt per centimeter along x-axis. Now the question is demanding field at origin. The field at origin may be greater than or equal to 20 volt centimeter, because the field has x component which is 20. Nothing is specified about y and z components. So if y and z components are there, field will be more than 20, and if they are 0, somehow if they are 0, then field will be equal to 20. So we should go with option A and C. But uh, oh sorry, with B and C, because it may be equal to or may be greater than 20. uh, it must, no, it will be less than 20. No, it can't be less than 20, as one of the component is given as 20. A vector cannot have lesser magnitude compared to its component. If one component is 20, the magnitude of vector will be either greater than 20 or equal to that. Which of the following quantities do not depend on the choice of zero potential or zero potential energy? The options are potential at a point, no. Potential difference, yes. Potential difference is independent of the choice of zero reference as well as the change in potential energy. Okay, so option B and D. Potential at a point is dependent. We derive the formula kq by r using potential at infinity to be zero. By definition, we can never find the potential of any point because only the thing that is defined is potential difference. So potential difference is absolute, it is independent of the reference as well as change in potential energy. It is similar to if someone asks you what is the height of any point. So reference is not specified, you will not be able to give the height. It may be taken from first floor, the height is 1 meter, or from the ground floor, it may be 5 or 6 meter, or from the top floor, the point may be somewhat having negative height below it. So height and potentials are not reference independent, but the difference between 2 points will be independent of the reference. Sixth one is an interesting one. A dipole is placed in an electric field which is generated by a point charge. Point charge generate fields in radial direction. So the field is variable as we move along the radial direction as well as we move along the tangential direction. So uh, no matter how we put the dipole, it will be placed in a non-uniform electric field which is produced by this electric dipole. So net force on the dipole must be zero, but the torque may or may not be zero because if we place the dipole along the radial direction, so force will be non-zero, but it will not experience any force or any torque. Okay, so if we place dipole along radial direction, no torque will be applied, but there will be force. But if we place along the tangential direction, tangential means draw a circle and draw a tangent on it and just place the dipole over there, then you will find that it will be experience torque as well as force on that. So we cannot put it anywhere so that no force will be there, but torque may be zero along the radial direction. In the next question, we have to find proton and electron are placed in a uniform electric field. As field is uniform, these two charges which are equal in magnitude and opposite in polarity will experience equal and opposite forces. So they will be equal in magnitude but not in direction. So they should not be called equal forces. So their magnitude should be equal. Their acceleration will be different because their masses are different. Okay. So their acceleration will be different both in magnitude as well as in directions. In the next question, field you have to find given it is given field is proportional to r and potential. As potential is can be found by integrating electric field. So if a field is proportional to r, field will be proportional to, or potential will be proportional to r square. If we integrate r, there is a power 1, it will be r square. If field is proportional to r square, potential will be proportional to r cube, and so on. Thank you.